Okay, this time we are looking to find the original length and the spring constant of a spring that is being tested by hanging masses vertically on the spring. So what we do is we hang a mass from the spring and measure its length. Then we hang more mass. We stop it from moving. We measure the new length. We collect some data where we have length in millimeters and mass in grams. Your data will look something like this. What you want to do is take that mass and convert it from grams to kilograms. You then want to use your formula that says the force of gravity pulling down on that mass is equal to 9.8 times the mass in kilograms. And do this for each of your masses. When you do this, you'll get a value of 0.43 newtons. You'll get 1.1 newtons. You'll get 2.8 newtons. You'll get 4.1 newtons. 5.6. And finally 6.7. Okay, once you have your forces and your spring lengths, you just want to graph them. So 0.43, 1.1, 2.8, 4.1, 5.6, 6.7. Okay, when we pull it up, we should get a linear graph that does not go through the origin. What we want to take away from this graph is the y-intercept. That will tell us the length of the spring when nothing was hung from it. And in this case, it's 145.6 millimeters. We then write that number down over here so we can keep track of it. 145.6. We take that number and we subtract it from each of the measured lengths. That will get us the stretch of our spring. Okay, and we do this for every single one. Okay, so then instead of graphing length versus force, we're going to make a new graph where we do stretch and force. Stretch on the x, force on the y. So let me take a moment to do my calculations. The first one, 168 minus 145.6 will give me a stretch of 22.4 millimeters. Next one is 62.4 millimeters. And I know that I want them eventually in meters, but for now it's just much easier to subtract millimeters from millimeters. 163.4. 225.4. 322.4. And last but not least, 375.4. Okay, once I have all of my stretches in millimeters, I'm going to move the decimal point 3 spots to get them into meters. I'm going to graph it, curve fit it, and you'll see it goes right through the origin. This time, I don't want the y-intercept. This time, I want to record the slope. The slope will tell me my spring constant, how hard it is to stretch the spring. And this graph tells me that the spring I used had a spring constant of 17.67 newtons per meter. Okay, to test whether or not I did everything right, I come back over here. I put in my name. I put in the spring constant. And I put in the original length. If all went well when I hit submit, I'll get a message telling me it was good It'll show me the correct values, and it will show you the values that I typed in.